Hello my viewers, welcome once again to my channel Israeli Math Concept. In this tutorial, I'm going to take you basically on circle theorem. In mathematics, we have different theorems as regarding to circle, but I'm going to be taking them one after the other. Do well to subscribe to my YouTube channel Israeli Math Concept and also to follow me on Facebook so that whenever I drop a new mathematics content, you will be notified. Basically, I will take this theorem on the board, which is the first one. Then in my subsequent video, I'm going to take other theorems as regarding to circle, because there are different theorems pertaining to circle. And any student that gets conversant or acquainted with these theorems will be able to solve any given question as regarding to circle. All right, I'm starting with the first theorem, 1. The theorem states the angle which an arc of a circle subtends at the center of a circle is twice that which it subtends at any point on the circumference of the circle. Alright, this is a circle. Assuming I label this circle P, Q, and R. This is a kind of way I have to make this circle to be known or to be identified by calling it P, Q, and R. Now, remember the theorem states the angle which an arc, the arc we are talking about is arc PQ. Because from this point through this point Q is the arc of the circle. And as well from this point P through this point Q is also the arc of this given circle PQR. But the arc from P to Q at this point is called the minor arc because it is smaller to the big arc from P through Q here, which is called the major arc. So the theorem basically is saying that the angle which an arc of a circle subtends at the center, this is arc PQ, and it has two projections here, which forms the angle as center. Assuming I call this center, this is the center of this given circle, I represent it with O. Now the theorem is saying that the angle which an arc of a circle subtends at the center, that means the angle, this angle that this arc subtends at this center of this given circle is 2 times or twice that which it subtends at any point on the circumference. That means the angle here is 2 times the angle here. Basically, this theorem is saying that if we have this very given angle R as theta, automatically the angle at the center here will be 2 times theta. That is 2 multiplied by theta, which is 2 theta. So the angle which this arc PQ of this given circle subtends at the center is 2 times the angle it subtends at the part of this given circumference. Alright, I'm going to make a proof to show that the angle at center of this given circle is 2 times the angle at this given part of the circumference. Alright, for us to begin this theory, the first thing we have to do is to say given a circle PQR, because this circle is circle PQR with center O, and the center of this circle we label it with O, or we represent it with O. Then what are we asked to prove? We are asked to prove, or we are trying to prove, that this given angle at the center, which is angle POQ, we are trying to prove that P angle OQ is equal to 2 times this angle here, which is P angle RQ. P angle RQ. That is what we are trying to prove. Now, if we must prove this theorem ideally, we must make a little construction. we must make a little construction. And what is the construction we want to make? We want to join R to O and project it to a given point T. Now I'm joining R to point O, and I will now project it to a given point T. So based on my construction, I will say join RO, join line RO, because this point I just drew is a line. So I join line RO and project it to a point T. So we've succeeded in joining line RO and projecting it to a certain point T. So we are through with our construction. So let's start with a proof. Proof. Remember, the difference between proof and proof is that when you say to prove, you are trying to state what you are asked to prove or what you are trying to prove. So we have stated what we are required to prove. Then for the proof means we have started the process of proving. So I write my proof, then I begin to say that obviously I observe that since I joined RO and projected it up to the point T, you can see that this RO is equal to this PO. The reason is because the radius of a given circle are always equal, and PO is the radius of this circle, and as well RO is also the radius of this circle, and as well from this point to this point is also the radius of the circle. Remember, the radius of a circle is the line that passes through the center of the circle to the circumference of the circle. So looking at this, obviously from O to Q is the radius of the circle. Then from R to O is the radius of this given circle. And as well from P to O is also the radius of this given circle, P, Q, R. The reason is because a radius is a line that passes through the center of the circle to the circumference. Then from my proof, I've started the process. I will now say that line PO is equal to line RO, and it is still equal to line QO. And the reason is because anything you write or you are proving, you must state your reason. The reason is because they are radii. Remember, radii is the plural of radius. So all these lines I've mentioned, PO, line RO, and line QO respectively, they are all radius of this given circle. So I group them with the plural radii. Then the next thing we want to prove is that we want to show that if this angle, because we automatically have two triangles here, which are triangle PRO and triangle QRO. Now, basically, you can see from triangle PRO, if I have the angle R to be A, automatically this angle here should also be, let me term it A1. You will discover that angle A is equal to A1. Why are they equal? The reason is because they are base angles of isosceles triangle. Remember, one of the properties of isosceles triangle is that their base angles are equal. That means if we have a triangle of this form, where the two opposite sides are equal, this type of triangle is called isosceles triangle, and automatically one of its properties is that their base angles are equal. So if this is triangle A, B, and C, automatically angle B and angle C should be equal because the base angles of isosceles triangle are equal. So basically from triangle PRO, that is this given triangle, you can discover that these two opposite sides of this given triangle PRO, they are equal. And because their opposite sides are equal, which are the radii, automatically their base angles are also equal. That is why I say that angle A is equal to angle A1. That is A sub 1. The reason is that they are base angles of isosceles triangle. Then obviously, since I also know that from triangle QRO or QOR, they are still isosceles triangle because this radius is also equal to this radius as regarding to this triangle QOR. So automatically I can also say that if I call here my B and I call here my B sub 1, that is B1, you can also see that B is equal to B1, and it is the same reason that there are base angles of isosceles triangle. Alright, the next thing I'm going to do is that I'm going to consider the angle at this very point here. Remember, the angle at this point should be 2A. 2A. So angle POT. Angle POT is equal to A plus A1. A plus A1. And A plus A1 is 2A. The reason is because I already stated that A1 is same as A. So substituting this A for this A1, then that A plus this A will give us 2A. And the reason for this is because the exterior angle of a given triangle is equal to the sum of the two interior opposites. Looking at this triangle PRO, you can see that the extension here is the exterior angle, that is this angle 2A is exterior to this triangle PRO. So automatically, for us to get this exterior angle of this triangle PRO, it should be equal to the sum of the two interior opposites, and the two interior opposites is A and A1. So automatically P angle OT is equal to A plus A1, which is equal to 2A, since we've known that A1 is same as A. The reason is because it is the exterior angle of a triangle, and the triangle is the triangle PRO. Triangle PRO. Alright, we can also see that in triangle QOR, the exterior angle is this given angle here, which is Q angle OT. So automatically the exterior angle of this Q angle OT should also be equal to 2B. Hence, Q angle OT, Q angle OT is equal to 2B. Q angle OT, that is this angle, is equal to 2B. And the 2B is gotten by saying B plus B1. That is the sum of the two interior opposites, B plus B1, which is 2B. And remember, B1 is the same as B. Hence, I substituted for B1 for B such that when I add B and B, we are going to get 2B. And the same reason which I apply to this, which is the exterior angle of a triangle PRO, the same thing is applicable here. So this angle is 2B, which is the sum of the angle here, B and B1. And the reason is because this angle here is the exterior angle of this given triangle QOR. And the exterior angle is equal to the sum of the two interior opposites. And interior opposite is B and B1. So we sum the two interior opposites to give us the exterior angle of this given triangle QOR. So in general, you can see that P angle OT plus or in addition to Q angle OT will give us the total of angle O. So we can now say that P angle OQ, P angle OQ should be equal to summing P angle OT is equal to summation of P angle OT plus summing Q angle OT plus Q angle OT, such that P angle OQ, P angle OQ is equal to P angle OT is what we solved here to get 2A. So P angle OT is 2A plus Q angle OT we solve to get 2B, hence we substitute it here to be 2B, such that we have P angle OQ is equal to, when we factorize 2A and 2B, 2 is common, hence 2 divide 2A, we are left with A, plus 2 divide 2B, we are left with B. So looking at this, the angle POQ, that is this angle O, is equal to 2 times the angle R, which is A plus B. So we have proved it already. So we put our QED, quod erat demonstrandum. Remember, QED means quod erat demonstrandum, which is a subject we write at the end of a proof or an argument. So this theorem is already proved. Remember what we proved is that this angle POQ, that is the totality of this angle here, is equal to 2 times the totality of the angle here. So automatically the theorem has been proved that the angle which an arc of a circle subtends at the center of a circle is twice that which is subtends at any point on the circumference of the circle. So automatically the angle which this given arc PQ subtends at this center of this circle is twice or 2 times the angle is subtends at the other part of this circumference, which is angle R. So the theorem has been proved. Thank you for viewing. Thank you for watching. Remember to subscribe to my YouTube channel, Israeli Maths Concept, so that whenever I drop a new maths content, you will be notified. Remember this given theorem, I will be applying it and solving practical problems as regarding to this given theorem. And don't forget to register it in your memory, how to state this given theorem, because the theorem states that the angle which an arc of a given circle subtends at the center of a circle is twice the angle which is subtends at the remaining parts of the given circumference of that same circle. Thank you for watching. Remember to share this video. Goodbye.